Okay, and we're going to talk about the infinite universe, and not only infinity. Also, we've got two things here. We have infinity and we have shape. Last time we discussed whether the universe is infinite or finite, right?
Well, what did we conclude?
And the issue, the issue is that the relativists, they want to include both. They say the universe is both infinite and finite.
Typical relativists.
Typical. And then from there, the question is, what is the center of that universe, right? And what we're going to argue is that if you have an infinite universe, you can't talk about, assuming there's such a monster, right? You can't talk about the center of the universe. That's the one issue. The other one is if it's a finite universe, yeah, then you can talk about it. But then the question is, how do you determine that if that's a question of an empirical issue where you determine when you run an experiment or you do an observation and you say, here's the center of the universe. Is that possible? Is that, at all within the laws of probability of man? Can we ever figure that out? Or is it a conceptual issue, right? That's one issue. And again, the other one is if it's infinite, well, forget about that. And so the problem here is that relativists make their universe both finite and infinite, as usually they have all these dualities. They cover all the bases.
Depends on what you're asking.
So it's easy to defend when you make no sense because you covered all the bases. That's the argument. Okay? And so the first thing we have to do in science is define. If we define, then we know what we're talking about.
Yeah, we know what we're asking.
And the problem is no one ever defined infinite or infinity. And here are the definitions you find today. This is out of the dictionary.
Here we go.
Okay? And infinite is an adjective, infinity is a noun. Okay? And then they have an adverb called infinitely. Okay? But the problem with this, as you can see in infinitely, it says boundlessly. If you just look at the green ones there that I marked there, they're talking about things. They're saying unmeasurable in extent of space. They're talking about a thing. They're treating space as a thing. They're talking about its extension. And they say it's unmeasurable. But unmeasurable is not a thing. Unmeasurable means I'm going to be doing something. Okay, it's what they're doing essentially is confusing bounded or unbounded with incessant or eternal or perpetual. What they're talking about is time or doing something over a period of time. They're talking about motion. So when they say the infinite nature of outer space, they're treating space as a physical object. And the synonyms they have for that is unbounded. No, unbounded can only refer to an object, and all objects are bounded. There is no boundless object. There's no endless object. All objects, by definition, are that which has shape.
Oh, by your definition.
Yeah, that's a scientific definition until someone produces a better mousetrap. That's the issue. And so there you have mathematical version. It says having elements that can be put into one-to-one correspondence, blah, 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 blah. Well, that has nothing to do with physics. Okay, in physics, we're just interested in what is the definition of infinite or infinity with respect to some entity, some object, something. Okay, can an entity, object, or thing be infinite, boundless, endless? The answer is no, because by definition, it's finite. It's got shape. And so if you don't like the definition of object, of thing, right, saying that which has shape, good. Bring one that you can use consistently, and we'll consider it. So, and then in the Wikipedia, you see at the bottom, infinity is something which is boundless. Absolutely not. There's no something which is boundless. And again, the reason is they never define what something is, or existence for that matter, and because of that, they never defined infinity.
Well, they're just not as nitpicky with the definitions.
Yeah,
in dictionary.com, which you think is their whole job,
but you have to be picky with the definitions in science, especially the most important words like what is an object, right? Yeah. Object, location, distance, those key words which form the foundations of physics, without which you can't do, right? You must define, and they better be defined, very crisply, very concisely, right? So that we understand exactly what you're saying. If you're going to define them and leave open-end, people go on a tangent and say, well, because the definition it's a loose definition.
There is a difficulty there because every word has a notion, which is this like cloud of criteria sometimes I say a word and you have a different cloud than I do, and they usually overlap on most of it. But when you define it, by almost necessarily, you're going to be cutting out chunks of that word that I actually want to keep in the word, and so on. And that's why defining words is so difficult, because when you try to define a word, you're defining it for you, for this discourse only, because that word usually means so much more in normal discourse, in ordinary speech. But but words are used in ordinary speech, so that word does have all these many meanings. I mean, the word God is the best example. Nowhere, if you can't find
God is love.
It's so many things.
God is intelligence.
God almost doesn't mean anything anymore.
Yeah, because God is everything.
Yeah,
they even define it as God is everything. Yeah.
Poor guy lost his meaning.
But this is the issue. The issue is even though there are overlapping regions, you have to find, can we use your definition consistently, objectively, and that's, I think, the ultimate criteria for any of these definitions, especially the ones that form the foundations of physics, right? Because if you're going to talk about existence, you're going to talk about what is an object. You can't do physics without objects, right? If you're going to talk about location, distance, motion, dimension, right? All those words need to be defined properly. Because otherwise they're going to create fist fights out there, because one person understands one thing, the other one understands something else. And I think
that's also that scarecrow straw man fighting thing that you run into, where you say, "Oh, look up, black hole." This guy says black hole means this. Black hole is zero dimensional. Then this guy comes and says, "No, I never said that. I mean this other thing with black hole."
Yeah, infinitesimal.
They just keep moving the goalposts. It's like, okay, pick one so we can tear it down.
Yeah.
That definitions make it.
And what I'm saying is that infinite does not, or infinity does not mean unbounded. It means incessant. Okay, incessantly. You're moving. You're talking about motion. You're saying you're going to measure. And if you look at the synonyms that you find in the dictionary, the only one that refers to a thing for incessantly is the word continuous. But that continuous is what we use in physics as an adjective. It is an adjective, not an adverb, right?
Yeah.
And it means something made of a single piece. Other than that, all the other ceaseless, constant, all those refer to motion.
I didn't know we were learning English.
Yeah, in fact, you got to start with definitions in science. Right?
In fact, I even told you like a week ago that it's almost like a new branch of science, which is semantic sciences. Because so many of these words just get thrown around, and we never get to the bottom of anything because we're just going in circles. And you've seen that when you see debates.
Because of
the lack of definitions. When you get into all these philosophical debates, philosophy is also a branch of science. When they never define the word truth, or they don't define the word God when they're trying to actually get to the bottom of the word God, like theists when they're talking about it, because they don't want to chop off parts of it. Because no, I mean that too. But if you mean too much, then it means nothing.
Yeah, you cover all the bases,
and then you just end up going in circles, and then everyone feels like they had a productive discussion. Everyone looks smart, but
everybody walks out there. Oh, that was a great time.
What the heck did we talk about? No one defined a single word.
Well, here you have one fellow. Everybody knows, I think, or remembers him. His name is Stephen Hawking.
That's a lot of text.
And he says the universe is not infinite in space, but neither does space have any boundary. What? What do you mean?
The universe is not infinite in space,
but it doesn't have any boundary. Okay? Neither does space have any boundary. Okay? He says gravity is so strong that space is bent around. He says he's going to curve the space around, turning it into a ball of some kind, right? A curve, right? And if one keeps traveling in a certain direction on the surface of the earth, one never comes up against an impassable barrier. So he's talking about two things. On the one hand, he says finite, and the other one, he says unbounded, when he really means incessant walking or incessantly, right?
Yeah.
Perpetual or whatever. One thing is finite, meaning, any ball is finite. Take your bowling ball, you'll find out it's finite. And then if you walk around the bowling ball, assuming you could, right? Or you walk around the earth, you're not talking about the same thing. Now you're talking about motion. And you're talking about really incessant walking, or you're talking about perpetual or something along those lines. So my conclusion is on this is the following, okay, is that a mathematician, it's an individual who doesn't understand the difference between an adjective and an adverb. Okay, he's talking about finite, which is an adjective, and then he's confusing that with incessant walking or incessantly, which is an adverb. And this is the problem with the language. That's why language is so important in physics, right? In science in general. And people don't pay attention to language. They say, "Oh, I understood," when they didn't understand squat. You know?
But the thing about it is, it isn't only the language, because you could also do a visualization, but they can't do that either. So in the end,
why? Because they're using concepts. Again, it's language.
It doesn't matter how whether they use
up
words or images, they can't get the message across, because the message is BS.
Right, because they're trying to give you a physical interpretation, and there's nothing physical about it.
There's nothing to convey.
Concepts, mathematical concepts, which they introduce as physical objects. Say, "Oh, I'm going to warp time," or "I'm going to, I don't know."
Travel through time.
Travel through space. Space is nothing. You can't travel through space or time. But they do that, and they bend the dimensions.
If you don't call it travel through space, what would you call an astronaut going from Earth to the moon?
Exactly what you said. You go to an object.
Not
I can only travel to. I don't travel through space. You can't travel through nothing.
Well,
you can travel through water. You can travel through air.
Yeah, travel through air.
But you cannot travel through nothing.
Oh, that's weird.
I can't travel through nothing. I can travel only through something.
Because that would be reifying space into an object.
Right, you're reifying. You're saying space has shape. Okay, then draw space. Draw the figure of space, and I know that I can travel through it.
Yeah, it's splitting hairs, but I guess if I said just travel through space, I mean, I hope I'd be forgiven for.
Okay, so here we have another issue related to that. Okay, here you have a fellow walking all around the earth, right? That's incessant walking. And the question is, good old Hawking, he says there's no bound. And he's wrong on that issue too, because here you see that there is a boundary, okay? It's the starting point where he left. He's covering the same ground. He's seeing the same atoms again, okay? So you can't say that I haven't encountered an obstacle. The obstacle is the finish line. That's what the obstacle is. Because now you're going back to Africa if that's where you started from, or back to North America if that's where you started from. Now you're going back to the same atom you started from. Okay, so you can't say, it's like if you go through every atom in the universe, right? Let's assume you can do that, you live eternally. You go through every atom in the universe. At some point, if there's only a fixed number of atoms, you're going to come back to the starting point, to that first atom. And so you can't say you walk incessantly throughout the universe in that case, which is the case here, right? You have to come to a finish line or to your starting point, whichever one you want to think about. Okay, so that's another thing you got to keep in mind. And what's worse is what they do next, and this is really should shock you. Okay, what is it? When they take a sphere and you focus in more and more and more on the edge of the sphere until it's so big that it's almost a flat, straight line,
like the Earth.
Right, and so this is where they say the Earth is finite, but it's also unbounded because it's flat, and the plane is infinite. Well, no, we got to keep it in the right context. If you started with a sphere, there's a curve there, and the fact that you, the observer, you, the measurer, the person who's measuring, cannot measure much of a curvature is irrelevant. You can't say, oh, it's completely flat. No, it ain't. And you can't say that it extends forever, meaning infinite, right? If what you're talking about is a sphere, there's always going to be curvature. You can't avoid it. And that's something for all flat earthers to think about.
I mean, if mathematicians are making the logical jump of making a ball straight, those are imprecisions that aren't really what mathematicians do. So I'm guessing they're just flat out lying.
Yeah, this is what they do. Here, watch it. I've illustrated it here.
Yep.
Okay. You have the sphere. Now you zoom in on the edge, right? You're going to zoom in all the way. And what are you going to come up with? Well, they come up with a straight line, which is the end result of this, focusing, right? So they end up with a straight line and say, oh, the Earth is infinite, the universe is infinite, or the Earth is infinite, or the circle is infinite. No, it ain't. A circle has curve, And I don't care how much you zoom in on that circle, it ain't going to be a straight line ever, much less an infinite straight line, which is the way they always picture it. This is what the mathematicians do with all their math. They say, oh, it turned an infinite straight line, okay? And so you can't do that. You can't say a circle, if I zoom in, at some point I'm going to end up with a straight line. No, it's always going to be a curve, sorry. And it's never going to be an infinite straight line for sure, because that's talking about going around the circle. Again, you know, we have to keep things in context, and the relativists don't do that, okay? And so what do they end up with all this after doing all their calculations and all that stuff? Well, they end up with these three universes. Either we have the finite spherical universe, or we have the other two possibilities, which is the flat or the saddle-shaped infinite universes. And the problem here is they start out with a finite universe with a sphere, and everybody more or less has to visualize that that's the case, because Big Bang happened at a single point, single time, right? 14 billion years ago. It's been expanding like a hand grenade, so you would think it's more or less spherical, right? And they say, well, yeah, that's Big Bang, but when we measure, we find out that it's infinite, like the flat board that you see in the lower right. And so and how do they reconcile these two? They say, well, if you focus in very closely to the edge of the sphere, you're going to find the infinite flat plane. That's how they do it. And so they get away with both worlds. They say the universe is spherical according to Big Bang, but it's also infinite according to, for example, the WMAP measurements.
It's finite and infinite.
Yeah,
it depends on what we need.
The only one they avoid is the saddle. I guess they don't like horses or something.
That sounds harder to explain, so they stay away from that one.
Yeah, but see, because they say it's open ended. But this is the issue is they're covering all the bases essentially. They're saying it's spherical and finite, but it's also infinite because it's a plane. And how do you get to the plane? Well, just focusing on the surface of Big Bang as it's expanding, and so big that for us, it's for all practical purposes, it's a flat line. And it's an infinite flat line because all planes are infinite. That's how they solve it. Yeah, and so what we have to do is teach them something here, and it's got to do with, what is the center of some of these figures that they're talking about. Well, here you have a square, or, a rectangle, right? Okay, I hope you all understand what a rectangle is, right?
Wait, before you go on,
yeah?
The center of something, does the shape have to be symmetrical?
No, because then you have the issue of mass, whether you have the center of mass, which would be lopsided usually. That's one issue, like the center of the earth and not the exact center, I'm sure. But then you have perfect geometric figures like the cube and so on, which are symmetrical, and you can say, okay, I can fix that center for sure. But then you have, rhomboids and so on. You say, well, where's the center of this thing? And again, you have those situations. Okay, but here's a rectangle. Okay, I hope you all understand what a rectangle is.
So far, so
and
good.
Here's a circle or a disc if you prefer. Okay. Here's a triangle. We have to do baby stuff here. I'm sorry, because there's a lot of people who don't understand what I'm going to say next, okay? And so I hope you've got all those figures way in your head, okay? Got them all?
Is there going to be a test on this?
Yeah, there's going to be a test on this. And now here's the infinite rectangle, okay? Here, watch closely. Here it is. Okay, that's the infinite rectangle, okay? And now let me show you the infinite circle.
Yep.
And there you see it again. Okay, and here's the infinite triangle. Okay, you got them all? Okay, it'll be a test on Friday. Okay, the infinite triangle, the infinite circle. Okay, yeah, if you have infinity,
it's not a shape.
First of all, you don't have a shape. You can't talk about a figure, which is what the geometry was supposed to be about, right? That's one issue. The other one is, where's the center of this thing? I mean, if it's infinite, assuming, let's just concede for the sake of argument. Okay, so it's infinite. You got an infinite square. You got an infinite circle, infinite triangle. Great, no problem. Now, where's the center of this infinite thing?
Well,
how do you know if it's the triangle, not a circle or a square?
Well, if you're talking about the perspective reality people, then they'll say wherever you're looking, the center of where you're looking would be the center of that.
Center of attention.
The crosshairs.
Okay, so this is part of the problem. Okay, let's concede the infinite universe first, because we're going to try to find the center of this thing, right? Okay, so here you are. You're in your little rocket ship, okay? You're going to be flying around, okay? You're going to fly to infinity.
Yep.
And you fly, you live forever. You're like God, right? And you're going to fly forever throughout the universe, okay? And the question is, can there be such a monster as infinity? where you travel forever. You don't die, right? You're there awake all the time. You can put your mind in the rocket, just say it's my mind traveling, no problem. I do it any way you want, right? You're traveling forever. You're saying you're not going to find an end to the universe. What does that mean? I mean, you could say that space is infinite, assuming
the black
you concede it. How about the matter? Is the matter also infinite? There's infinite matter, infinite atoms. There's never a point where the number of atoms stops or space itself stops. What are you talking about then? Well, what is infinity? And again, for that you need to define infinity, and you have to define infinity for objects. You can't say, well, it's incessant walking, incessant traveling on my spaceship. No, you have to relate it to physics, and physics deals with objects. You have to tell me, if you're going to talk about matter, if you're going to talk about space and treat space as a physical object, then you have to define what you mean by infinite space. What is infinity?
I really love
an infinite object.
I really love the gift that you put there, because I instantly thought of, because I develop video games, the way you fake infinity, like that gift, is you take the dots that go off screen and you put them on the front like a treadmill. And you have it going like this.
Yeah, which is incessant motion and not infinity.
That's as if you were traveling on. That's as if you were traveling on a hamster wheel. Yeah, but that doesn't mean there's an infinite number of stars. It's just you're recycling them.
One is that you're going to come back to the same stars. Yeah. That's one issue. But the other one is, in one case, you're talking about objects. You're talking about whether all objects are finite. So you can't use the word infinite in a context of objects. The other one is you're talking about incessant motion or perpetual motion, which has nothing to do with the shape of an object. Now you're talking about running around. Yeah. One has to do with objects, the other one has to do with motion.
That's the first thing. Just as well walk in circles on this and call it infinite.
Right. Say if you're going to come back to the starting point or to the finish line, whichever one you prefer, then you're not infinite. You don't have to have a wall there like Hawking said. It's unbounded because you don't come up against the wall. But you came back to the same atom. That is your wall. Yeah. Okay, so you can't say it finite but unbounded. Yeah. What you can say is finite, but you can walk incessantly around it. That's the correct wording. Not to say it's unbounded. Unbounded refers to an object. Objects are bounded or unbounded. Not unbounded. They're all bounded, but he's misusing the language there.
By definition, you'd think that something that's bounded means that you could walk as much as you want on it, but at some point you'll be retracing your steps. That's what bounded means.
Exactly.
Sooner or later,
in that context.
Right. Sooner or later, you will touch on.
Important to get the context and the language right. Infinite, finite. No object that is infinite. Okay, so one fellow says, he makes a correct statement as far as I'm concerned, okay? He says there must be but there must not be infinite material objects in the universe. There is definitely nothing, also known as empty, unoccupied space in between objects. And yeah, that's the assumption we make here, that the amount of matter in the universe is fixed. You don't have unlimited atoms.
There is a number.
There is a number, we have to keep in mind that it's a dynamic situation. Maybe an atom turns into a neutron and vice versa. Okay, there's things going on, right? But this is the issue. The issue is we do not create new matter in the universe. Space does not convert into matter. Matter cannot convert into space. That's why the universe had no beginning. Could not have had a beginning like general relativity concluded. And
that's my favorite answer to the universe question. When they talk about creation and all that, it's much simpler. Matter just always was. Matter always will be.
And here it is. Let me show you all that there ever was or ever will be. It's the single thread. That's all there was. Now this thread, right, which is out there, not that we'll ever see it like that. This is just a conceptual thing that if we untie every atom in the universe, every rope that connects them, that's what we would end up with. Where does this go? Well, from there we go to this. We go from the single closed loop thread to a universe in which all atoms are physically interconnected.
But this is conceptually, so it didn't really go from a single closed.
Well, I'm not saying that. What I'm saying is there was no process that brought from the single thread to all the atoms. I don't think there was a process.
This is just so that we can understand what we're talking about.
Right. And it's just a conceptual issue saying that if we were to untied
it is
or
possible
unknot.
to unravel the universe to a closed loop thread, but only theoretically in common sense.
And so I'm saying that the basic system is two atoms bound by a rope. Okay, and so what we've been seeing all these years, the wave is not a wave, a two-dimensional transverse wave. It's a rope that we've been pondering all these years, and they've mathematized it to extinction almost. I mean, we did so much math on this thing, and it was always a rope. That was how simple it was. Yeah. All we need to figure out is what invisible entity is mediating light and gravity, and that's our suggestion there. Okay, that's what we propose as an assumption. And all these atoms form that, what you see on the upper right there, all the atoms in the universe are interconnected. And if we were to unravel that whole universe, we would end up with a single closed loop thread. It'll never happen, never happened. It's just we're trying to analyze it conceptually. Okay, yeah. So let's keep that in mind. Okay, so
I love the concept of a finite ball universe because it kind of puts to rest so many of these questions that just never have answers. When you conceptualize it like that, answering a lot of big universe questions becomes much simpler, I noticed.
Yeah, because it's baby stuff then. Anybody can understand because you can see it there in front of you. Yeah. Doesn't mean you have to believe it, but at least you make sense of it.
Yeah.
You don't have to believe it, you just got to make sense of it.
I mean, if you can answer much more questions like that, then you think that that's the right answer, right?
And here we have Father Universe. Father Universe exists in a single frame of the Universal movie. Okay, that's what he looks like. That's his face. Yeah, he's
two galaxies, a planet.
That's Father Universe. Every atom in the universe only has location. That's all Father Universe recognizes. Father Universe, Mother Nature, God, the devil, whoever you believe in, right? It doesn't matter. All we have is atoms in the universe, everyone at a given distance from each other in one frame of the universal movie. If good old God or the devil could take a snapshot of the universe for us, this would be a 3D special type of photograph where you can see every atom in the universe, right? That would fit in a single frame. Yep. So there is no such thing as time for Father Universe. That's why he's eternal. He's eternal because he's in a single frame of the universal movie. He is timeless, should we say?
What are we trying to answer here?
Well, I'm saying that, if because I'm getting to the point of the center of the universe, right? Okay. So if the center, if good old Father Universe, right, fits in a single frame, all we have to ponder or visualize, right, every atom in the universe. Just imagine you could visualize all that, all the atoms in the universe. And we're going to freeze the entire universe. We're not going to have any motion, so time and motion, they play no role here. All we have is existence, right? Single frame, every atom there. What would the universe look like first? And then if we can more or less imagine that, can we figure out a center of the universe? In this case, his nose is in the center.
So you're saying if we zoomed out on the universe.
Right. If we could be a bird's eye perspective, right?
Yeah.
If we can have a bird's eye perspective,
God's eye
we're sitting there next to God, right?
Yeah.
We're looking at the universe.
With them. Would it be a ball we're looking at, a donut, a cylinder, a triangle?
So here's a couple ideas. Here's one. Imagine that all atoms in the universe, meaning all planets, all stars, all galaxies, they form, from a bird's eye perspective, right? They form some kind of ball, right? That's one possibility.
This seems like the first thing we would think of.
And the issue here is that one thing is that the whole thing could be moving. And here I put it rotating clockwise. It could be in different directions, right? But one thing is that here we have also almost a perfect ball. It doesn't have to be so perfect, right? But gives you an idea what you would see for the universe if you were far away. The amount of matter has to be fixed.
Yeah.
In other words, some of those atoms can turn into neutrons or whatever, or maybe the rope extends in one direction and one atom disappears. I don't know. All these little details have to be ironed out.
But whatever
I'm saying the amount of matter, the single thread, if we were to unravel all these atoms, would be a fixed amount because a single thread does not extend. It's not a rubber band. Okay, it's just a fixed amount of matter, we could say. And forms a certain amount of matter that forms our universe. What's the black stuff that continues what? Infinitely? No. The black stuff is that which has no shape. That's why it's infinitely.
Because it is by definition not something.
Right, it's not something. So you
I guess it's the
you
only
use
thing.
An adjective on it.
You know, like just in ordinary speech, it might be the one thing you could call infinite, even though it isn't something that.
Yeah, but
we
need to get the wording proper in there. You can't use the word infinite at all because if it's an object, it's finite, and if it's
it ain't
space,
an object, then
it ain't an object. You can't talk. You can't use an adjective.
There's something weird about that gift though. Seeing all the matter like in front of you. Yeah, it's just kind of weird.
Well, here's another version. Okay, this is another possibility. We're not going to cover the million ones, but here's a donut-shaped universe. Okay, and we were discussing with Aunt here the other day this thing whether the universe could be like donut-shaped, and they do talk about that. These are different possibilities. And one of the reasons we went with a donut idea is that you have atoms on one side. Let's say the east side of the donut, and you have atoms tied to them that are on the west side of the donut. The advantage of this model is that you don't have gravity towards the center of the donut, because the center of the donut is nothing. There's nothing there. Okay, that's the idea, or something for you to ponder. You would
have gravity towards the center because.
But I mean, it's unlike the Earth, where the Earth there's matter in the center.
Yeah.
Here's no matter in the center of this donut, right? And you have atoms on the east side pulling on the west side, north pulling on the south. You do have that, but what you don't have is a preponderance to go to the center of the donut. That's all I'm saying.
Well, the reason I was arguing for the shape of the entire universe being a donut was the magnetism, the way you explain magnetism.
Yeah, you're getting ahead of yourself. Hold it. Let me show that now. Okay, so now we're going to factor up, because we have the issue. This is the problem. Let me tell you what the problem is. If all the ropes are all the atoms are pulling through ropes to other atoms, you have all this massive, all these atoms on one side of the universe pulling on atoms on the other side of the universe. Yeah. How do we handle this? Because shouldn't everything go towards the center? Or shouldn't the whole ball compress itself and turn into a black hole or whatever they call it?
No, don't bring that up.
No, we don't want to bring that up. So what you have to ponder, another thing that we want to include here, is the magnetic field. Magnetic field.
But what the question specifically is why has all the matter in the universe not collapsed onto a single ball, or just gone out?
Which is what Newton asked. He said, why don't all the galaxies, he didn't know exactly about it. Why don't they crash and fall a single ball?
Why does matter keep its distance as it is? Not completely on one spot and not completely far away from each other. It seems to be that something is maintaining everything where it's supposed to be.
Right, and here's the one solution that we propose, and that's the universal magnetic field.
I love this.
Okay, we have a universal magnetic field, and you have to imagine that all galaxies have a magnetic field, all stars have a magnetic field, all planets, well, not all, but a lot of planets have magnetic fields, especially if they're big. Yeah. And so the issue here is this would be the universal magnetic field. You have the universe, a ball type universe in the center, and you have all these threads that are just swinging around, and they're going to help push things apart or maintain a certain stability to the universe so that everything doesn't collapse gravitationally.
So the concept is something like any atoms that go to the center get slapped I guess in this case it would be slapped up.
Well, here you see here's the cylinder. And again, let's assume the cylinder is there and the magnetic fields go through the center of this, it will not allow any matter to be in that center, and that's why in that case the universe would be cylindrical. Donut shaped.
Yeah. Any matter that goes too far out gets slapped back in. Any matter that goes too far in gets slapped back in. And it's almost like the bounds of our universe. In a way.
Right. So the issue is this is homework for anyone who wants to take on it. What is the shape of our universe? Maybe it's a cylinder shape. Maybe you can factor in a cylindrical shape or triangular, pyramidal.
I was personally rooting for the ball universe because I kind of like the idea of the ball having the same shape as an atom.
Yeah.
But the more I thought about it, the donut one makes more sense.
Yeah, the donut one, we like the donut one more. I didn't like the donut one a long time. I even discarded it completely. Now I'm bringing it back.
I think I like the donut universe because
it might solve some problems.
Because the magnetism of the universe slapping. Yeah, exactly.
There's our universe, folks.
The magnetism, man, Homer Simpson would love this. But the magnetism slapping anything that goes to the center or too far out because it's literally going in and out.
In and out. So it doesn't allow any galaxies or stars to be in there.
Hold on, but I would say it's still not a perfect donut. It's more like a cone donut because assuming the magnetism slapping everything up, that means matter would shoot up and then come back in. So it'd be more like a cone donut. That would be my guess.
Yeah, or a thicker donut, maybe
or
a cylindrical donut, or something like
that. That'd be my guess.
That's Homer for you folks.